All right, so we're going to wrap up what we're talking about today about circles with arcs and chords. So we've talked a little bit about what a chord is. And a chord is just, again, is it a segment or a line? A chord is a segment, so it has two endpoints, and it goes from one part of the circle to another. So it has to touch two different spots on the circle. And an arc basically connects those. So an arc is an unbroken part of a circle that consists of two endpoints. So essentially, an arc is just part of the circle. So EF would be an arc, FG would be an arc, EFG would also be an arc, EG would be an arc. It's just parts of the circle. Arcs are curved sections of the circle. A central angle is an angle whose vertex is in the center of this circle. So for instance, this angle X right here is a central angle because B is the center of this circle, and it connects from the center to the two outsides and it makes an angle. Okay, so that's an arc. I'm sorry, that's a central angle and this is an arc. So there's a relationship between them. The measure of an arc is equal to the measure of the central angle. So going back to the slide right here, for instance, let's say this right here, this angle ABC, is equal to, let's say 60 degrees. That means arc AC is also equal to 60 degrees. Okay, so we measure arcs in degrees, just like we measure angles in degrees. How many degrees are there total in a circle? 360. There's 360 total in a circle. So that means if X were 60, then what would the arc AC going this way be? 300. Why? 360 minus 60. Good. So we call this right here a minor arc. And then we call this the major arc. The major arc is outside, and the minor arc is inside. So the minor arc goes from the central angle onto the circle, and that's that one. Why do you think they call it minor? Smaller. And then the major arc is essentially whatever's left over. And to find the major arc, you just subtract the minor arc, or the central angle, from 360, because it's just whatever's left over. All right, a semicircle is always going to be how many degrees? 180, because that's half of
a sphere. A circle.
360. Half of 360. Good. So a semicircle is an arc that takes up 180 degrees. It's half of it. The measure of the semicircle will always equal 180. Okay, so we can use that to figure out the parts of circles when we do things like pie charts. So this pie chart, for instance, tells me that 25% of the music sales at this store were rock music. So 25% of that were rock music. So if I wanted to figure out the measure of this arc, AB, how could I do that? How do you think I could do that?
What's 1/4 of 360?
What are you doing? Why 1/4? 25% is the same as 1/4. The whole circle is what? 360. So then this would just be 1/4 of 360. So how would I find that? Okay, which gives me? So this ends up actually the AB, the arc AB, would equal 90 degrees. Okay, same would go for the angle AMB. Because AMB is this angle right here. Arc AB goes with angle AMB. Does that make sense? AMB is the central angle. AB is the arc that goes with it because it connects the two sides of that angle. So for instance, if I'm talking about DMC, the angle DMC, what arc would go with DMC? DC. Yep, DC would go with DMC because that's the arc that connects the two sides of this angle. Did I just lose you? So say for instance we're talking about this angle. What angle is this? HMA. And what arc goes with HMA? HA. So you would say angle HMA is equal to arc HA. Because HA is the arc, the part of the circle that goes with this angle. Still no?
I get it.
All right, so that means if 26% of the music sales were other, how could you figure out how many degrees this arc and this angle would be?
26 over 100 equals x over 360.
So we're gonna find 26% of 360. There's a couple different ways to do it. You can do it as a proportion. I just use a decimal. What decimal is the same as 26%? 0.26, and I just multiply that times 360. All right, you can use a calculator, you don't have to use a calculator, however you want to do it. $93.60. So this angle would be equal to 93.60, which means that arc is also equal to what? 93.60. So they're exactly the same. All right?
So it's going to be the same, also the same thing for like the little one?
Yes, the arc and the angle that it goes with will always be the same. But what if I asked you, like the question asks you to find the measure of arc BC, but what if I asked you to find a measure of, let's say, what if I asked you to find BCD? What is BCD? It's basically the combination of rap music and R&B music. So what would you do to figure out that angle? Add it together and then multiply that percent by 360. Good. So in this case, this is 13, this is 11. So add it together is 24. So we do 0.24 times 360.
And that's it?
Uh-huh. That's it. Which is, Siggy, can you do that for me? 86.4. Yeah. Thanks. So that's 86.4 degrees. So if the measure of arc BCD is 86.4, what angle is 86.4? DMB. Good. So that's the angle that encompasses that entire arc. Okay? So again, the arc and the angle have the same measure. And all the way around should add up to what? 360. If it doesn't, you did something wrong. Okay? But typically you're not going to do that here because you're not going to figure out every one of them and add it together. So just trust yourself. Okay? I always just turn it into a decimal. You can do it however you want. If you want to turn it into a fraction, that's fine. I'm just lazy and that's easier. Okay? So I always turn it into a decimal and then just multiply it times 360. Will this ever be different than 360? No, because if we're talking about circles, it will always be 360. All right. So the arc addition postulate, we've had several addition postulates. Our first one was segment addition postulate. Our second one was angle addition postulate. And essentially all the addition postulates say is if you add together two parts, what do you get? The whole. If you add two parts together, you get the whole. So for instance, AB plus BC gives you what? Yep, Angel, say it louder. Good. So arc AB plus BC equals arc AC. All right, so those two pieces will add together to give you the whole. We call these two pieces adjacent arcs because adjacent means right next to. So RS and ST are adjacent arcs. Down here are CD and AB adjacent arcs. CD and AB.
Yes.
Are those adjacent arcs? No, why not?
They're not right.
They're not right next to each other. If they're adjacent arcs, they need to share what?
On the same side.
The same, the middle letter needs to be the same. So like here, A, B, B, C, those are adjacent because they both share what letter? B. They both touch B on the circle. Here, these don't share a letter, so those are not adjacent arcs. Okay, now, I want to figure out the measure of CDE. So CDE is right here. I'm going to make this a little bigger. Okay, and I want to figure out CDE. What do I know?
Wouldn't DE be CD adjacent equals 90?
DE is adjacent to CD, that's true.
CD equals 90.
Yeah, CD equals 90. How do you know that?
Because
Yeah, this red square tells you this angle is how big. And if the angle is 90, then this needs to be 90 degrees. Okay, so if that's 90.
BFE is 18?
BFE?
Yeah.
Like the whole BFE?
No, D.
Oh, DFE. This angle is 18. Why? Why? They're vertical. So if this is 18, what's this? 18, which means DE is what? 18. So then how would you find CDE? Add them together, which will give you 108. Yep. Yep. Okay, so vertical angles are equal to each other. 90-degree angles are going to give you a 90-degree arc. And when arcs are adjacent, you just add them together. What is arc BAE? What is arc BAE true? What is it? How many degrees?
180.
180. It has to be 180 because it's what part of the circle? Half of the circle. So if I know this is 18, could I figure out AE then?
Yes.
Yes? 180
Minus 18.
minus 18. Good. Okay, 180 minus 18. So if I figure that out, I can basically work backwards to figure out every single one no matter what they ask. So you're typically going to use either 180 or you're going to just go with the angles that they have. All right, so this is probably hard to see on your slides, so you might need to look up here, but you're looking for these four, AMD, DME, BC, and CBA. And I'm going to write these a little bigger if you need them. But go ahead and try these four. And remember, if they're all percents, you've got to multiply them by 360. After you turn them into what? Decimals.
Ms. Brown,
Yeah.
can I go get my phone?
Where is it?
My Catherine took it.
Can you? All right, so then the last part kind of connects some things that we learned about arcs, or basically just what arcs and chords are, and how we put those together to come up with different theorems about circles. So things that are true about circles. So in a circle or congruent circles, if the central angles are the same, the chords that connect those arcs are also congruent. So for example, right here, see these little blue lines? Like the blue line here and the blue line? Okay, so ED would be equal to CB. So the chord that connects those two angles are equal if the angles are equal. And that same thing works backwards. So these chords, ED and CB, if they are congruent, then you know that the arcs are equal, and you also know that the angles on the inside are equal. So essentially, if you know one of those three pieces, the arc, the chord, or the angle is congruent to the other one, then you know all three are. Okay? So again, I'm going to draw this just a little bit bigger. Okay. So which ones are the chords?
A, B, and C, D.
A, B, and C, D. So the blue segments are chords. All right. If they're congruent to each other, what do I know about angle AXB and CXD? They are congruent to each other also. And I also then know that arc AB is congruent to arc CD. So basically, if one of the pieces is congruent, all the pieces are congruent to each other. The arc, the chord, and the angle. Okay? That doesn't mean that if this is 12, this is 12 degrees. Okay? That just means if this is 12 and this is 12, then if you know this is 60, this one is also 60. Okay? So it's like a line of congruency, basically. If one of the pieces is congruent, then they're all congruent to their corresponding piece. So the angle goes with the angle, the chord goes with the chord. However, the angle in the arc should be what? The same. So if this is 60, what's CD?
660.
CD would also be 60. Alright, and if CD is 60, what's 80? Also 60, because it has to be congruent as well. Okay? So the arcs and the angles should be the same. The only ones that shouldn't be are what? The chords, because the chords are not measured in degrees. They're just lines. So they're like 2 inches long or 6 inches long or whatever. Those are our usual measurements. Arcs and angles are in degrees. Okay, so that means in this case, what could you say? Since you know that these arcs are equal, or I'm sorry, since you know that the chords are equal, what can you say about those two arcs? They have to be equal to each other also. So how would you solve for x here? Alright, so solve that. Minus 2x, which would leave me with what? X equals. Okay, so then how would I find RS? Plug it in. What's 3 times 27? 81. Alright, and that's an arc, so it's 81 degrees. Same thing over here. If I know that arc AC is congruent to DF, then what do I know about these two angles? They're congruent to each other also. Okay? So you just set them equal to each other. So if the arcs are the same, the angles have to be the same. If the angles are the same, the chords also have to be the same. So we could say DF, this chord, would be congruent to what chord up here? CA or AC. All right, Rosie, what was your question?
Do you have to solve both of them? Do you have to solve them?
Like if you plug this in and get 81, do you have to plug it in to find this one too? No, because you know that if this is 81, what should that be?
81.
So really, you can just pick whichever one you think is easier to do. I think that one's easier because it's just times 3. All right, I'm not going to do this one, but same thing, right? So we do 7y minus 5 and then add 12 to the other side. I'm sorry, add 5 to the other, 43 to the other side. Okay, the last thing has to do with radii and chords. So in a circle, if a radius or a diameter is perpendicular to the chord, then it bisects the chord and its arc. So bisect means what? Goes through where though? Right in the middle, right? So if this is perpendicular, then what can you tell me about this and this? These are the same. Okay? So it bisects that. And then backwards, if these two are equal, then you know that these two things are perpendicular. So it makes 90 degrees.
So just say that this equals this?
Yes. The two pieces equal each other. And what we'll use that for is to find missing pieces by using the Pythagorean theorem. So take a look at this one. I want to find BD. So I know AE. I know that EC is how much?
2.
And CA is how much?
3.
So that means the whole thing is
5.
5. This is a radius, right?
Yes.
So from the center to any point is going to be 5, which means this dotted blue line is also 5. So now what shape do I have right here? A triangle? What kind of triangle? A right triangle. If this is 3 and this is 5, how can I find this? I can use the Pythagorean theorem, which would be what?
What?
3 squared plus
25.
x b squared equals 5 squared.
So 9 plus b squared.
Minus 9. Square root of b equals 4.
So then this must equal 4. So if this is 4, then how long is BD? 8. Because if this is 4, this is 4. So BD, whoops, equals 8. All right, BD equals 8. So you can always make a right triangle here, and you know that if this is 5, this one has to be 5 because they're both what? Radii. Yep, they're both radii in the circle, so they go from the center to the end. So whenever you have a right triangle, you can use the Pythagorean theorem. Okay, try these 2.